All right. Hi, everybody. Bear with me as I have not ever done this screen capture presentation type thing before. We'll see how it goes. My intention today is to show you some of the stuff you can do with PyMOL, with the PDB files that I've asked you guys to download and look at. I've asked you to make a couple of figures. I'm not going to go through every single thing that I've put together in the protocol or everything that I've asked you to do to generate these figures. But we will walk through some ideas that may make things a little bit easier for you. There's a lot you can do with PyMOL, and of course what you decide is a good figure is to some degree subjective, but as long as it conveys the information in a clear manner, that's fine. You may have different preferences about color or background or transparency. All of it's valid, as long as I said, you can make out the information that's meant to be conveyed. So what I've done here is I've loaded up PyMOL, and I've opened, and this is a PyMOL, this is the version that's most up to date for my Linux system is 1.7. Yours may look slightly different, you may be using PyMOL 2.2. But it basically just opened up the lysozyme molecule that has the ligand with it. So you guys will find the PDB, you'll open it up, and hopefully you'll be presented with something like this. Now, as you can see, I'm already starting to manipulate the molecule a little bit. I'm just rotating it. And what I'm doing is I'm using my mouse. Touch screens are usable with PyMOL, but the mouse is actually probably a little bit more useful. So a mouse and keyboard combination seems to be the most powerful. You can see down here, if you follow my cursor, I've currently got the mouse mode set up for 3 buttons. So it shows different things you can do, hitting shifts, controls, control shifts, et cetera, with the left, right, middle, or wheel. With the left mouse button, I can basically hold the molecule and spin it around. If I had a middle button, I could move it in particular directions. The wheel is actually used for slab, which means that if I rotate the wheel, I can kind of change the depth of the molecule behind sort of a hidden black wall behind the molecule. But probably the most useful one is the rotation. Now, you may actually also use translocation, where you move the molecule side to side, but that's fine too. If you don't have a 3-button mouse, you can go up here to the top and change the mouse to a different mouse setup, whatever is most appropriate for yourself. So one of the first things I asked you guys to do, if you have a look at this molecule, you've got all these little red X's floating around all over the place. They are the water molecules. So as we mentioned in lecture, salt crystals and sugar crystals, and crystals we're more used to thinking about, tend to be composed of just the molecule in question. So salt crystals are just sodium and chloride. Sugar crystals are typically just glucose. Protein crystals contain a lot of solvent molecules mixed in with them, and that's what we're showing here. So when electron density maps are generated, they tend to show the solvent molecules as well. Now, that's fine, and it can give us some information about the basic subunit of a protein crystal, but they're not going to be much use for us for our figure, so we can actually hide those fairly easily. Up here you can see that there is a button showing all and a button showing lysozyme with ligand. Now this lysozyme with ligand is just what I've renamed the PDB. You may have an alphanumeric name for your PDB, and that would show here. These buttons will actually show or hide the entire molecule. So if I hit this button, it just disappears. Similarly, if I hit all, it will also disappear. Now that on its own is not too super useful, but we'll be able to use these buttons a bit more in a moment. First thing we're going to do, though, is we're going to get rid of some of the extraneous information here. We're going to make things a little bit clearer right away. What we can do is get rid of the non-bonded molecules. So that, in this case, are the water molecules forming part of the solvent. So if we go down here, hide, non-bonded, boom, there we go. Water molecules are gone. Now, for those people who may be concerned that the ligand is not actually covalently bonded to the lysozyme, and maybe it disappeared as well, that's not the case, because the ligand itself contains covalent bonds, and so it's classified as a bonded molecule. And in fact, the ligand is right here. And we'll make that more clear in just a moment. So, we've got the ligand and the protein that it's bound to. The ligand is NAG, which is a subunit of... Apologies, there will be some pauses in this video because the lab is going on, and I do have to pause once in a while to answer questions. So the ligand here is kind of an artificial subunit. It's a part of a peptidoglycan, pardon me. It's the NAG subunit, and it's in a repeat. So if we had opened the PDB file in a word processor, we would be able to see that the ligand is designated NAG. So all the residues inside the ligand are designated NAG. We can select those using this command line down at the bottom, and this is all indicated in the protocol. So I'm going to type in select, and I'm going to name this thing. So this is where we put the name. So I'm just going to name it ligand. Then we're going to add a comma, and then I'm going to ask the selection to be all residues named NAG, capitalized. Oops, I'm going to spell it right, NAG. So we hit enter, and there we have it. The ligand is now highlighted. And we've named it ligand, and you can see that actually comes up here. Now, you notice this in parentheses. This means that this ligand is now a subsection of our lysozyme with ligand molecule, but we can separate that and make it maybe a little bit easier to manipulate. I think sometimes it is a little bit more robust if we copy that to an object. So now we have an object. Now we can actually, at this point, get rid of that selection. We now have lysozyme with ligand, we have object. So whether it's there or not, we can't really make it disappear, but we can manipulate it. So let's rename this just to make things a bit clearer. So it's called object 1. So remember, we took our selection and we exported it to an object. I'm just going to rename it ligand. There we go. And you know what? We're going to change the way it looks. We're going to turn it into a stick figure. There, that makes it quite clear. So right away, we've got a lot more visual information here about where our ligand is in relation to lysozyme. Okay. Now, it's maybe a little bit gaudy. Atoms are automatically colored in PyMOL based on the PDB and what those atoms actually are. Let's maybe change that. We're just going to make it flat out red. So our ligand is now maybe more contrasty against the background. So far, so good, I think. Now, other things you can do here in this interface. Let's say, for example, I've asked you to select a particular amino acid from within the lysozyme. And there's a couple ways you can do it. One, if you hit this S button down here at the bottom, and I didn't cover this in the documentation, but it's pretty straightforward. If you hit the S button, you now have a list of the single amino acid chain that makes up lysozyme. So if we wanted to select this particular amino acid, it's right down there at the bottom. We can unselect it as well from there. Similarly, we could have selected the ligand. We can select each of the NAG subunits separately or unselect them. Another way we can do it is by simply putting select and then naming it whatever we want. Let's say we want to find all the tryptophans. And in fact, I've asked you guys to find a tryptophan that lines up with the the ligand. So let's do that. So let's find all the tryptophans. So let's call it TRPS. And we're going to do residues, residues named TRP. And there we go. There's all the tryptophans within the lysozyme. Now, right away, we can see some of them are a little bit too far away from the ligand to be the one I've asked you guys to line up against the ligand, but there's a couple down here that might qualify. This one probably doesn't quite line up. This one looks like it might be doing a bit better job right here. What I'm going to do is I'm going to use the mouse. I'm going to use the right button. I'm going to zoom in a little bit so that we can actually see that a bit better. Oops, sorry. That is not what I wanted to do. Rotate that. Still not super clear, is it? Well, that's part of the thing that we're going to fix. So here's a tryptophan side chain, and it seems to line up reasonably well with the cyclic areas on the NAG. So we want just this particular tryptophan. Well, that's possible as well. So which one is it? You see we're selecting and deselecting molecules here just by clicking on the image. If I look up here, that one was tryptophan 62. Let's remove our tryptophan selections. Now let's go in here and we only want tryptophan 62. We want to make sure we get that right. So let's do select TRP 62 just to give it a really boring name. And I'm just going to call it residue 62. Now in this case, you notice it's different from residue named. It's residue, so it's just residue 62. If we hit enter, it will highlight it directly. And you notice up here we now have a new subselection, an object. It's not yet an object, but a subselection of TRP 62. Let's say I want to copy that to an object. There we go. We can, again, delete the previous selection. I'm going to rename this so that it's, again, reasonably clear. I'm just going to call it TRP 62. Okay, so let's change how it looks again. Let's turn it into sticks again to make things a little more obvious. And there we go. So we have tryptophan rings here, which line up reasonably with this molecule. And to make that even maybe a little clearer, let's get rid of everything else. Okay, so there you go. So we can see the tryptophan amino acid and this ring structure on our ligand that line up reasonably well. Let's bring the lysozyme back. If we only want to highlight the side chain of this tryptophan, we can go under the tryptophan, we can go under the H menu, which is hide, and we can hide main chain. Now, because we've called this out as a separate object, the main chain is still there as part of the larger object, which is lysozyme with ligand. But we now have the side chain highlighted. So I think that's on our way to getting some figures going here. A couple other things I'm going to point out. We can add a surface to this molecule if that makes it easier for us. So if we were to go under our lysozyme with ligand and do show and surface, it'll cover the whole thing. Now that is ugly, but there is ways you can fix this up. You can change the color scheme, of course. You can change its transparency, and that's actually something we could do here. Set transparency, comma 0.5. So there, we've got information about both the underlying structure and the surface. But honestly, that's a little bit more information than I want right now. So let's hide that surface again. All right. Now, another thing I've asked you guys to do is to find polar contacts between the ligand and the molecule itself. Now, these are hydrogen bonds. Now, maybe the easiest way for us to do that is to start with our ligand molecule. Let's say actions, find polar contacts. And there's another submenu here. Do you want it within selection? Well, no. Do you want it just involving side chains, involving solvent, excluding solvent? There's a lot of things here. Let's get a large number of hydrogen bonds to just see which ones might be interesting. Let's say to any atoms, to any excluding solvent. We're not too concerned about hydrogen bonding to water molecules at this point. So let's do that. There we go. So that's a reasonable number of hydrogen bonds, but it's maybe still more than we want. You can see some of them are intramolecular rather than intermolecular. All right, apologize everybody. I had to go and answer another question just now. If I can remember where we are. Yeah, so we had our hydrogen bonding displayed here, or at least polar contacts. As we mentioned, some of them are intramolecular, which is not that interesting to us, whereas I'm asking for contacts, potential hydrogen bonding between the ligand and between side chains on the lysozyme itself. So we can see there's a couple here to this particular atom. There's maybe one over here, but here's an interesting one we'll focus on. There's one that goes actually to the tryptophan that lines up. So again, these are potential. These are what PyMOL think is maybe hydrogen bonding. Doesn't mean it's actuality, but let's see if we can isolate it and just show this particular hydrogen bond. So to do that, maybe what we'll do is we'll remove the rest of the hydrogen bonds. Let's keep an eye on which atoms are involved. So there's one here and one here. So let's remove the rest of the hydrogen bonds. So we'll just bloop, get rid of that. Now, rather than at this point starting from the ligand and finding all the hydrogen bonding, let's pick the atoms that were involved and ask for hydrogen bonding from that particular atom. And there's a little trick you can do. We're down here where it says selecting residues. You notice if I click on tryptophan, I get the entire tryptophan, but I can't just select a single atom. But if you go down here to selecting, I just clicked on selecting. You can select chains, segments, objects, molecules, C-alphas, atoms. Done. Okay? So we now have a new selection. And just before I go too far, I'll turn that back to residues. I'm going to call this out as its own object again just because I'm kind of obsessive that way, and we'll get rid of this original selection. So now we have an object that corresponds to just this particular atom. And you know what? Let's rename it. Oh, what the heck just happened? Okay, that's interesting. Okay, I must have hit zoom. That was not what I wanted to do. So let's isolate that a little bit by using our slab on the wheel. Okay, let's rename this. Oh God, quit it. Apparently if you click on this, it zooms. We may have discovered a bug in PyMOL. So I'm going to click on it and I'm going to scroll down and I'm going to rename this object atom 1, just so it's separate. Now, if we go to atom 1, which is a new object here, we go down to, oh, I did it again. I'm going to keep doing that. Apologize, everybody. Zoom back out. Click and hold, so we get around that bug in PyMOL. Let's find polar contacts with any molecule excluding solvent. And there we have it. So we have our nice hydrogen bond shown just on its own. Now let's zoom out, just see how we're doing there. And I'll show the rest of the molecule here. There we go. So we're actually starting to deconvolute all the information here reasonably well. Alright, sorry, I had to pause again there. I really should not have been doing this when the lab was on. So, it's still probably a little bit busy, and it's not the complete picture of what I've asked you to do. Some of the other things I've asked you to do is identify positively and negatively charged, or potentially positively and negatively charged side chains, to show differences between the lysozyme structure on the binding or absence of ligand. And you do that by superimposing the two images, but there are some reasonable instructions, I think, on how you do that. But I think this has covered some of the basic stuff. Just trying to think of some things that I haven't covered. We can change the background color, for example. We can make it light gray instead, which is not super. Depends on what kind of color scheme you've chosen or what kind of structure you've chosen for the rest of the molecule. Again, it's going to be fairly subjective as to what you think is a reasonable image, and as long as it conveys the information and isn't too busy or too overwhelming, I think that's reasonable. Again, you don't you don't have to show the entire molecule in your figures. You can zoom in on things that are more interesting. So hopefully that's covered some of the basics, and you should be able to figure out some of the rest of the stuff I've asked you to do using some of this material. Remember, the selection tool is quite powerful. You can use hide, you can call objects, and hopefully that covers the basics. Obviously I'll be around to answer any questions, and I may actually run through some of this during a lecture next week, but hopefully this is enough to be going on. So good luck, everybody. I hope to see some really nice lysozyme and ligand figures.